Supervise the learning after clustering. Clustering, like the dimensionality reduction methods discussed in Chapter 6, can be used for two purposes. It can be used for data exploration, to understand the structure of data. Dimensionality reduction methods are used to find correlations between variables, and thus group variables. Clustering methods, on the other hand, are used to find similarities between instances and thus group instances. If such groups are found, these may be named by application experts and their attributes be defined. One can choose the group mean as the representative prototype of instances in the group, or the possible range of attributes can be written. This allows a simpler description of the data, for example, if the customers of a company seem to fall in one of K groups, called segments, customers being defined in terms of their demographic attributes and the transactions with the company, then a better understanding of the customer base will be provided that will allow the company to provide different strategies for different types of customers. This is part of customer relationship management (CRM). Likewise, the company will also be able to develop the strategies for those customers who do not fall in any large group and who may require attention, for example, churning customers. Frequently, clustering is also used as a pre-processing stage, just like the dimensionality reduction methods of Chapter 6 allowed us to make a mapping to a new space. After clustering, we also map to a new k-dimensional space where the dimensions are hi or bi at the risk of loss of information. In a supervised setting, we can then learn the discriminant or regression function in this new space. The difference from dimensionality reduction methods like PCA, however, is that k, the dimensionality of the new space, can be larger than d, the original dimensionality. When we use a method like PCA, where the new dimensions are combinations of the original dimensions to represent any instance in the new space, all dimensions contribute. That is, all zj are non-zero. In the case of a method like clustering where the new dimensions are defined locally, there are many more new dimensions bj, but only one, or if we use hj, few of them have a non-zero value. In the former case, where there are few dimensions but all contribute, we have a distributed representation. In the later case, where there are many dimensions but few contribute, we have a local representation. One advantage of preceding a supervised learner with unsupervised clustering or dimensionality reduction is that the latter does not need labeled data. Labeling the data is costly. We can use a large amount of unlabeled data for learning the cluster parameters and then use a smaller labeled data to learn the second stage of classification or regression. Unsupervised learning is called learning what normally happens. That is Barrow proposed in 1989. When followed by a supervised learner, we first learn what normally happens and then learn what that means. We discussed such methods in Chapter 12. In the case of classification, when each class is a mixture model composed of a number of components, the whole density is a mixture of mixtures. Thus, the probability of x conditioning on Ci, which is equal to the summation of the probability of x conditioning on Gij times the probability of Gij, summing for index j starting from 1 to kl, and the probability of x is equal to the summation of the probability of x conditioning on Ci times the probability of Ci. Again, the summation is summing for all index I from 1 to k. Now, where the upper limit of ki is the number in the probability of x conditioning on Ci is the number of components making up the probability of x conditioning on Ci, and Gij is the component j of class I. Note that different classes may need different number of components. Learning the parameters of components is done separately for each class, probably after some regularization, as we discussed previously. This is better than fitting many components to data from all classes and then labeling them later with classes.